Okay, in this video, we're going to continue with complex numbers, but I kind of wanted to do the stuff that's a little bit different. So I figured we could do the easier stuff first that feels a little bit more natural, and now do some of the different stuff. So here, this is what division looks like. We don't do long division with complex numbers. What we do instead is we're going to multiply by the conjugate of the denominator. And the reason that we're going to do that, is because when we multiply by a conjugate, it actually cancels all the imaginary stuff out and we get a real number, because we really don't want to have imaginary units in our denominator. So that's our goal here. So dividing really just means to have no imaginary units in the denominator. So we want to just be in standard form. This is definitely not in standard form, right? It's not a plus bi. Oh, my computer is being... All right, hopefully that stays. All right, so here I have 3i. If I can lock that, okay. I'm just going to rewrite the problem, and then I'm going to multiply by the conjugate. So remember the conjugate, if one of the values is a plus bi, then the other value is a minus bi. That's all it is, a change of sign in the middle. So I'm going to multiply the top by 4 minus I and the bottom by 4 minus I. So I'm using the conjugate of that denominator. And now you're going to use your multiplication techniques. So what we're going to do here is we're going to go ahead and distribute that 3i. So let's see, I get 12i minus 3i squared. And in the denominator, I'm going to do the same thing. I'm going to FOIL or distribute that out. So I start with the 4 here. So 4 times 4 is 16, and then 4 times negative I is negative 4i. And then I go to the next piece. I times 4 is 4i, and I times negative I is negative I squared. And what's going to happen, which is what you want, is you're going to notice those imaginary terms in the middle cancel. Negative 4 plus 4 is 0. Okay, so I'm going to keep simplifying. I have a 12i minus 3. Don't forget I squared is negative 1. I'm going to change that over. And then same thing in the denominator. I have this I squared here. So careful, it's a minus. And then I squared is negative 1. So I have 12i. Here my negatives will cancel, plus 3. Here my negatives will also cancel. So I have 17. Now we're almost done. Notice I've gotten rid of that I in the denominator, which is what I want to do. But I still need to write it in standard form. So standard form is that a plus bi. I want the real part first, imaginary part second. I want a distinct plus sign in between. So I don't have a giant fraction here, right? I have 2 distinct parts. So what I'm going to do is separate this out. So I have 12i over 17 and 3 over 17. And then the last thing I need to do is make sure the real part comes first. So a positive 3 over 17 comes first, and then a positive 12 over 17i comes second. So that's how we divide. We're actually not doing any sort of long division here. We're trying to clear out that I in the denominator so that we can write it in standard form. That's our goal. All right, let's do another one. So I'm just going to rewrite this to make it easier to see. And we always use the conjugate of the denominator. So if it's a minus here, I'm going to use a plus. And then we're just going to multiply. 7 times 2 is 14, and 7 times 5i is 35i. On the inside part here, 4i times 2 is 8i, and 4i times 5i is 20i squared. In the denominator, 2 times 2 is 4, and 2 times 5i is 10i. Negative 5i times 2 is negative 10i, and negative 5i times positive 5i is negative 25i squared. Those are going to cancel out, and I'm going to keep simplifying. So I have 14, and then here I have like terms, so I'm going to add 35 plus the 8 and get 43 with the I. If I see an I squared, that's negative 1. In the denominator, those middle pieces cancel. I have 4 minus 25, and again, that I squared is negative 1. Back over here. So I have 14 plus 43i, and then minus 20 over 4. Now my two negatives here will cancel, so 4 plus 25. Keep combining like terms. 40 minus 20 is negative 6 plus 43i, and then in the denominator I have 29. So I'm almost there. I'm not quite there yet. I do have to separate this out. So remember, I want a distinct real part plus an imaginary part. So that 29 is just going to get split to both pieces. And that ends up being our final result here. Now, if you do have fractions, just as a side note, you would want to simplify your fractions if you can. Now, there's nothing I can divide out here to reduce these, so we're done. You don't need to change this to a mixed number. Usually in this form, we tend to leave it as an improper fraction unless it says otherwise. But it's actually much easier to read as a improper fraction rather than a mixed number here. Okay, so let's talk a little bit more about that imaginary unit. So how can we simplify things like roots like this? So for any positive real number b, the principal square root of the negative number negative b is defined as this. So what happens is when you have the square root of negative b, you really have a negative 1 times that b under the root. So we end up splitting this into two parts. And what happens is this first part is just I, right? This is the imaginary unit I. So that's how we get that breakdown here. When you see a negative inside the root, you can take that out and make that the imaginary unit I, and then you have the leftover part inside. So again, really what you're doing is you're taking out that square root of negative 1 here to get the leftover. Now, one thing I want to note is you could also write the I after the root. So you could write it like this, square root of bi. But it's often hard to read. It's a little bit hard to read like this. So we tend to put the I out front. And one thing you should note is the I should never be under the root. So that's another reason why we don't write it this way, because a lot of times people will be careless and they'll do something like this, which is wrong. So that I is outside the root, which is why we tend to write it first, although both of these are still correct. The other thing I want to note here, which is important to get the right answer, is that when you're performing operations with square roots of negative numbers, you want to, the first thing you want to do before you start multiplying or adding or doing anything like that, is you want to express those square roots in terms of I. So make everything using the principal square root here first, and then you can start operations. So for instance, for this one, I have that negative 81. So if it helps you, you know, this is square root of negative 1 times the square root of 81, right? And this piece here is that I. So this becomes I root 81. So anytime you see a negative, you can just bring it outside as an I. Now we're going to simplify. Square root of 81 is just 9 because 9 squared is 81. This is just 9. But we don't usually write it that way. We like to write it with the 9 in front now. So unless there's a root, we usually write the I at the back of it. But if there's a root, we make that exception and put it out front because it's easier to read. For this one here, same thing. It's really negative 1 times that 75. So this here is your I. And then now you want to work on simplifying that 75. So here's something that you may not have seen in a while. 75 is not a perfect square like 81 was, but we can simplify it. So if you think about 75 and I think about possible factors, 25 times 3 is one possible factor. And 25 is a perfect square, right? It's 5 squared. So when you have a root that is not a perfect square, but could be broken down such that one of the factors is a perfect square, then you're going to keep simplifying. So what happens here, I'm going to do this just kind of off to the side for a second. That square root of 75 becomes the square root of 25 times the square root of 3. When we're multiplying here with roots, you are allowed to break it apart like this, not for adding and subtracting, but you can't for multiplying and dividing. So we break it into our two factors, and then we take the square root of the 25 here, which is 5. Okay, so we are able to break it down a little bit, even though it's not broken down completely. So bringing this all back together, then you would have I times 5 root 3. And usually what we do is we write it as 5I root 3. So we kind of put that I next to the 5, but still in front of the root. If there are no symbols in between, this is assumed to be multiplication. So this is 5I times root 3. Again, you could put that I at the end, but this tends to be the more standard way to write it. All right, let's do a few more examples like this together. Now here, I do have a bunch to do underneath the root first. So you still would actually follow order of operations. And a square root is sort of like a grouping symbol because it keeps everything together like parentheses does. So I am going to clean that up first. Here I have 25 minus, and then I'm going to go ahead and have, 12 times 7. Okay. So let's see, 12 times 7 is 84. And then when I simplify this, I have negative 59. Now at this point, again, I see that negative in the root. So I do want to simplify that. So it's the same thing as the root of negative 1 times root 59. So I have I root 59. Now, if I think of 59 here and I try to break it down like the 75, I'm not going to get any factors that would be helpful. 59 is not a perfect square. It does not have any factors that are perfect squares. So this is going to be as good as it's going to get here. Now for this one, again, underneath the root, there's nothing to do. That's different than this one. So I don't want to do my multiplication first. I do need to make these having i's before I do any sort of other operation outside the roots. So this one here, right, would be the same thing as 5i because it's root negative 1 times root 25. And this one here is root negative 1 times root 4. So it's going to be 2i. Square root of 4 is 2. And then here we have I. Now I'm multiplying these together. So I have 10i squared. And then don't forget that I squared is a negative 1. So my answer here is negative 10. As a side note, I do want to note that this here would be wrong. So if you did not simplify first and you try to multiply these together, right? Negative 25 times negative 4 is positive 100. You get the wrong answer. If you get positive 10, not negative 10. So you always want to do the i's first and then do outside operations on the roots. Again, this one was different because everything was under the root. So I do it on simplify underneath the root. But here, once I have my roots are pretty simplified, I need to change the I form before I do any sort of outside multiplication or addition or anything like that. Okay, let's do a couple more. So we're going to do the same thing here. I see a subtraction, but I got to change to that I form first. So this is negative 1 times 18. So I have I root 18. And then very similar, I have a minus sign here. It's going to be root negative 1 times 8. So minus I root 8. I can break some of these down though. So if I think about square root of 18, well, 18 is the same thing as square root of 9 times the square root of 2, right? 9 times 2 is 18. So this does have a perfect square factor here because the square root of 9 is 3. And then for 8, this also has a perfect square factor because it's 4 times 2, and that 4 is a perfect square. So this becomes 2 root 2. So actually, if I continue with my question here, I have I times 3 root 2 minus I times 2 root 2. And just to write that a little bit better, we usually write it as 3I root 2 minus 2I root 2. So that's a little bit nicer here, a little bit easier to read. Now, there's one last thing we can do here. And working with roots is very similar to working with variables and like terms. If you have the same kind of root, you can add or subtract it as well. With multiplying, we can basically do whatever we want, right? Because we don't need like terms for multiplication. But for adding, subtracting, you do need like terms, and you would also need like roots. But these are like roots. They both end up having square root of 2. So what you do is that square root of 2 comes down, and then you subtract those outside numbers. So you're doing like 3I minus 2I. Well, 3 minus 2 is just 1, right? So this becomes 1I root 2 or just I root 2. We don't need the 1 in this case because 1 times I is still I. Let's